Hello everyone, today we're going to be working on fundamental problem 6.7, and this problem is asking us to determine the force in members BC, CF, and FE, to state also if the members are in tension and compression. So it's given to us to take that P1 is equal to 480 pounds and P2 is equal to 640 pounds. So I'm going to just quickly write that on our image figure. So we said that P1 is equal to 480 pounds. And then from there, we said that P2 is going to be equal to 640 pounds. So now that we did that, the next thing that we're going to do is we're going to be solving this problem using the method of sections. So to do the method of sections, to use the method of sections, usually you want to cut at a certain place, angle, or however you want to say it, to be able to determine for the bars that are being asked to that are that they are asking you to solve. There you go. So I'm gonna do my cut right here. That's gonna be my cut because when cutting like this, we are going through the bar FE, which is one of the bars, FC or CF, which is right here, and BC, which was the last bar that was given to us, that was asked to be to determine their force. So now that we have cut the truss in half, from there you get to decide which side of the truss you're going to work with to be able to determine the forces. So I'm going to quickly look at both sides to see which side would be easier to work with, because there is usually an easier side to work with. So if I were to look on the left side, if I were to take the left side, you could see that I would be dealing with one of the forces, P1, but I would also be dealing with my two supports that I have here. I have two pin supports, meaning that I would have to determine their reactions. So here we would have 4 reactions plus the force. So the first step would be determining the values of the reactions and then using the method of sections. Now, if I were to look on the right side of the truss, you could see that I would just have to uh, deal with the forces P1 and P2. I wouldn't have to find no reactions. I could quickly or straight just go into using the method of sections, which is why I'm choosing to work with the right side of the truss. So I'm quickly going to draw out the figure of it. So we're going to have this bar, which is going to be our bar EF. From there, we have our point D, which will be somewhere over here. And then from there, we have where we cut the bar. So we have our bar EF. We have our bar FC or CF. And then we're going to have our bar BC. From there, I'm going to assume that the forces or the bars are going to be in tension. Then later on, if I get a positive number, that means I assume it correctly. If I get a negative number, that means that they're actually going to be in compressions. But for right now, I'm just going to assume that they're in tension, so away from the joint. So I'm assuming that they're in tension right now. So this is going to be the force of the bar EF. tension, so away from the joint, the force of the bar CF, and once again, in tension, the force of the bar BC. Oh. And then from there, we would have our joint F right, sorry, not, this is, sorry. This is our joint or point C, there you go. So from here, we would have F, and then we would have B. So that is my sketch. If we were to cut the truss right here, that's basically what we would be seeing. From there, we know that we have our two forces, one of 480 pounds and one of 640 pounds. From there, we know that from here to here, we have a distance of 4 feet. And then we know that also from here to here, we also have a distance of 4 feet. There we go. So just quickly, just so we could use this for the future, since we're going to need this, as you guys could see, we know that this side of the triangle has a length of 4 feet. This side of the triangle also has a length of 4 feet. So we know that this triangle right here has a slope, or better said, it is a 1 square root of 2 triangle. So we're going to need that for later on. So now that we have that, the first step that I'm going to do to use the method of sections, as you guys can see, we already drew out. I'm going to be taking the sum of the moments about point C. Because if I were to take the sum of the moments about point C, to start off, we know that the 480 pounds would not be creating a moment. The force of the bar BC will also not be creating a moment. Since the force of the bar CF is at an angle, we know that it has a vertical and horizontal component to it, and those vertical and horizontal components to it, since it has them right here, they will also not be creating a moment. So the only two forces that are going to be creating a moment would be the 640 pounds and the force of the bar EF, meaning that we could use that to solve for this bar. So while taking the sum of the moments about point C, we know that has to equal 0. So we said that we're only going to have two forces creating a moment. Remember that moment is equal to the force times the distance. So here at point D, we have 640 pounds. We know that this is going to be creating that clockwise moment, meaning a negative moment, with a force of 640 pounds times the distance of 4 feet, because from here to here is 4 feet. From there, we would have our force of our bar EF. We assume that it's going to be in tension, so in this case, it is going to the left. We know that's going to be creating then a counterclockwise moment, meaning a positive moment. So a positive moment of our force, that is what we're trying to determine, times the distance. And our distance here is, we have our force right here, and we know to get to point C, we have a distance of 4 feet. So once again, times 4 feet. all of that has to equal 0. So from there, we would end up getting that force of the bar EF times 4 feet has to equal 2,560 pound-feet. So if we were to solve for the force of the bar EF, we would end up getting a value of 640 pounds. We got a positive number, meaning that we assumed correctly. So that means that it is going to be in tension. So now that we already determined one force, the next step that I'm going to be doing is I'm going to be taking the sum of the moments. So I'm going to be taking the sum of the moments about a different point. This time I'm going to be taking it about point F right here. Because if we were to take it there, we know that the force of the bar EF will not be creating moment. Once again, the force of the bar CF has a vertical and horizontal component that will not be creating a moment about that point. From there, we would only be having three forces creating a moment, which would be the force of the bar BC. From there, we would have the force 480 pounds and the force 640 pounds. You could also take the sum of the forces in the x direction if you guys would like to. It's really up to you guys, but I'm just going to be taking the sum of the force, the sum of the moments about point F. I'll probably show how to take the sum of the forces in the x direction as well, showing how you would get the same answer in the end. So counterclockwise positive, the sum of the moments about point F have to equal 0. From there, we said we only have three forces creating a moment. So first, we have our force of our bar BC, which we assume that's going to be in tension, so away from the bar joint. Here we have it going to the left, meaning that for our point F, it's going to be creating that clockwise moment, meaning a negative moment of our force, which is what we're trying to determine, times the distance of 4 feet. So we said negative moment of our force BC times 4 feet. From there, we have two forces on the right side of the point going downwards. So we know that both of these are also going to be creating a clockwise moment, meaning that they're both going to be negative moments. So quickly looking at this, uh, the force for the first one is going to be 480 pounds, but the distance is going to be 4 feet. From here to here is 4 feet. Now for point 2, it's going to have a force of 640 pounds, but the distance from here to here is 8 feet. So we're going to write that down. So both of them are negative moments. The first one has a value of 480 pounds times the distance of 4 feet. The other one has 640 pounds with a distance of 8 feet. And all of that has to equal 0. From there, we would end up getting that the negative force of BC times 4 feet has to equal 7,040 pound-feet. So when solving for the force of the bar BC, we would end up getting a value of negative 1,760 pounds. Since we got a negative number, that means that we assumed incorrectly at the beginning, meaning that it's going to be in compression. So now that we determined this one, now to solve for the last and final bar, which is our force of our bar CF, I'm going to be simply taking the sum of the forces in the x direction. You could also take the sum of the forces. Sorry, I'm going to be taking the sum of the forces in the y direction. You could also take the sum of the forces in the x direction since the force of the bar CF has both a horizontal and vertical component to it. So once again, we said that this has a slope of 1 square root of 2, and we could tell that this triangle right here as well, 4 feet, so 4 feet here. So we know that this force right here has a slope also of 1 square root of 2. So to determine that vertical component of the force CF, we're going to be multiplying the force of CF by, when looking at this as a triangle, we're trying to determine the vertical component, so we're going to be multiplying it by 1. Now, in this case, you may get confused since both of the sides are 1, but let's say if this had a value of 2 and this side had a value of 3, then we would be multiplying the force of the bar CF by 2 over square root of 2. Meanwhile, we were trying to determine the horizontal component of it, so this side, we would be multiplying it by 3 over the square root of 2. So in a way, whether determining its horizontal vertical component in this example, it would be the same. But remember, I'm multiplying it by 1 over the square root of 2 because I'm taking the vertical component of that slope or triangle. So taking the sum of the forces in the y direction has to equal 0. We would have our 480 pounds and 640 pounds going downwards. And then from there, since we assume that our force of our bar CF is in tension, it has to go away from the joint. So in this case, it would be slanted upward. So here it would be a positive force. Positive force. But remember, we said we're trying to find the vertical component of it. So we're going to multiply the force of CF, of the bar CF, by 1 over the square root of 2. And that all of that has to equal 0. So if we were to do that, we would end up getting that 1 over the square root of 2 times the force of the bar CF has to equal 1,120 pounds. So if we were to solve for the force of the bar CF, we would end up getting a value of 1,584 pounds. Since we got a positive number, it means that we assumed correctly, so that means that it will be in tension. So with that, we were able to determine the forces of the 3 members that were asked. So once again, the first step that I took to determine the forces in these members is first you want to cut the truss in a way that it crosses all the bars or all the members that are being asked to identify their forces. So that's why I cut it down right in the middle in this example because it goes through all of those 3 members. From there, I quickly took a glance on the left and the right side of the truss and saw that working with the right side of the truss would be much simpler than working on the left side with the truss. And then from there, I just drew out my truss, and then from there, I just took either the sum of the moments about a point, the sum of the forces in the y or x direction. Thank you guys so much for watching this video. If you guys found this video helpful, please feel free to give it a thumbs up. And if you guys would like to see more videos like this, please feel free to subscribe to our channel.